So building rockets are fun. It's a physics-based game where the player controls a rocket through touch. In this video, I'm going to give that rocket fuel, and we're gonna display fuel gauges to the player so that they'll know how much fuel they have left. Let's jump into Swift Playgrounds and see how this is done. First, we need to create the variables that are gonna hold values for fuel. Like I said, we're gonna have 3 different values, but we're gonna wanna display these on content view, which means we need to pass data from game scene, which is SpriteKit, over to content view, which is SwiftUI. That means we're going to need to have bindings and published variables and just to keep track of the data, which means the first part of this is to create a new file called GameDEV. All right, and this GameDEV file is a class. GameDEV is an observable object. This will allow us to see this object in our SwiftUI and write to it from SpriteKit. So we're going to have 3 variables here: published var red fuel, and we'll just set these all to 0 to start. And we'll have a blue fuel, and we'll have orange fuel. So this is our game data so far. We'll build on this as the game progresses. We'll add more data that we need to pass back and forth. For now, we'll just deal with fuel. Now we're gonna set it up in SpriteKit. So we come to our game scene, we're gonna need to create some bindings. So we need a binding for a private var red fuel, and this will be an int. And we'll also do a binding private var for blue fuel, which will be an int. And add binding private var orange fuel, which is an integer. And now because we have bindings here, we're going to get an error because we need to initialize these separately. So we're going to have an init red fuel, and this is a binding int. We have blue fuel, which is a binding int, and we are going to have orange fuel, which is also a binding of type int. Inside of this initialization, we are going to set these red fuel equals red fuel, blue fuel equals blue fuel, and orange equals orange. That will allow them to be initialized. And then we also have to call the super init size, and we're going to do the size of our scene, which is 600, 600, and we will do self scale mode equals .fill. And then, of course, the last piece of this is we need to add required piece here. This, you can just click fix, and it's all set. So now we have our bindings inside of game scene, so now we need to write to them. The first place to do that would be in didMoveToView. We will want to give them an initial value when the player launches the game. So let's set red fuel equal to 15, blue fuel equal to 25, and orange fuel equal to 15. And then of course, when we use our fuel, we're going to subtract from that. So we will have, when you come in here and you are using your fuel to rotate to the left or to the right, this is going to be orange fuel minus equals 1. And then we will have red fuel minus equals 1. And of course, blue fuel minus equals 1. So now we are removing our fuel. All right, so we have to get that data from SpriteKit over to content view. But before we can do that, we need to create an environment object for our game data. And this is going to be of type game data. And then inside of our game scene, we can then do, so inside of here we have red fuel binding. So we need to do $game data.red fuel. And then for our blue fuel, we'll do $blue fuel, or $game data.blue fuel. And then for our orange fuel, it's the same process, $game data orange fuel. Now these will update. I like to put these all on separate lines so that they're a little easier for me to see, especially as we add more data to the game scene that we need to pass back and forth. So to make this also work, we have to make sure that our content view here inside of my app has that environment object game data. This just allows it to work. And then now to display this fuel to the player, I came up with an interesting idea. Inside of SwiftUI, there are charts. It lets you build charts like bar graphs and stuff using SwiftUI elements. They look pretty cool. They're really easy to build. So I said, well, can I just build those and update them in my game? So I gave it a shot, and I think it looks pretty cool. So to do this, I need to import charts, and that gives me access to the charts that SwiftUI has available to it. It's pretty interesting what we can do here. So I'm going to actually come down to our body. I'm going to replace our title with a text called fuel. And then under here, we're going to have a chart, which then has some parameters. So this chart is going to be for bar marks, which are basically a bar graph. We're going to have 3 of these, but let me do one first. So we have an X, which is a value, and it's going to be fuel. And we will do red. So that's your red fuel. And then we have a Y value, which is the value. And this is total. And we're going to do game data dot red fuel. So this is going to display how much red fuel we have. And then we will have a bar mark. And this one will also have an X value. You know what, we can just copy these. And we'll copy one more. And let's clean this up. And then this one is going to be of type fuel, but it's going to be blue. And it will be blue fuel. And this one will be orange. We will have orange fuel. Now, what we need to do is make sure things display properly. So we're going to have dot foreground style dot red for the red fuel, and then dot foreground style dot blue for blue fuel, dot foreground style dot orange for orange fuel. And then, I don't really want all of this stuff being hidden or being shown, so I'm going to do chart y-axis dot hidden and chart x-axis dot hidden. That needs a dot. So now we just have the colors, which I think is enough for people to understand, hey, these are my fuel gauges. And then we're going to have a frame of a 300 by 80. And we will actually keep the alignment. We'll do dot center just to ensure it stays in the center there. So now we have our fuel gauges, and theoretically it should already work. As I move, you can see it actually looks like the blue is getting, or the other ones are getting bigger, but it's just a relationship, right? So as we use fuel, and then once we run out, now we're below 0, you can see that's kind of how it goes. But we need to fix this. We need to build, maybe a game over or stop people from being able to use fuel when they don't have fuel. So that's pretty easy to do inside of game scene. So inside of game scene, basically, if orange fuel is less than or equal to 0, we will just return, right? So we're not going to allow the player to do any more rotation here. Same thing here for red fuel, and we will do the same thing again for blue fuel. So that kind of gives us an idea of how this fuel gauge will work. We could refine it even more over time, but basically now, as I go through all of these things, once I rotate all the way, I can't do any more rotation, right? Or I can't go anywhere. Like once this is gone, it's gone. And now I can't tap, and I will eventually fall back to the ground. So now we need something to do. We need we need a way to refuel, and B, we need to have more to do in the game. So there's a number of ways we can do this. I'm still trying to work out exactly what I want to do. So as a temporary solution, what I've come up with is inside of my game scene, I have another SpriteKit, another SK Sprite node called Fuel Supply. And this is going to be an SK Sprite node. And we will have our fuel supply dot size, which is a CG size. And we're 65 by 50, so a little bit of a rectangle. And inside of here, we're going to have an array called fuel supply colors. So we're going to have 3 colors. They're going to be UI colors dot UI color dot red, UI color dot blue, and UI color dot orange. And then we also have to keep track of how many are on the screen so that we're not like overburdening people. So I have a fuel supply count, which equals 0 to start. So now let's create the function for spawn fuel supply. So I'm going to base how the fuel supply is spawned on the current rocket position. So that way there'll always be a fuel supply kind of close-ish to the player. It might not be the right color, but it will be close to where the player is. So we're going to get the rocket position, which is a SIGI point. And then we're going to return an SK Sprite node. So then what we want to do is have these spawn in a position that's kind of close by, but on the game board. So I'm going to get a low Y, which is going to be the rocket position dot Y plus 50, then a high Y, which is the rocket position dot Y plus 500. And we'll do the same thing for X. Let low X equal rocket position dot X plus a negative 250. I don't know why I did that. How about I just do minus 250? Makes more sense. And then let high X equal rocket position dot X plus 250. And now we also need to get a random color. So we're going to say a random color equals int.random in 0 to 2. Okay, and now we're going to spawn our fuel supply. So we're going to do fuel supply equals SK Sprite node color, and it's going to be fuel supply colors, and this is going to be the random color number that we get. So whatever, it's either going to be 0, 0, 1, or 2, and that will correspond to the 3 available colors in our array. You could also do, instead of that, another way to do this would be let random colors equal fuel supply colors dot random element. That might work better because then if you add more colors, you don't have to remember to update your random. Yeah, let's do that. Let's do it this way. I'm changing my code on the fly here. Random color. I'm going to keep the same thing here. I'm just going to change how I handle it. And then, and then CG, and this is a size. This is going to be fuel supply size. So then we need a position, fuel supply dot position equals CG point. And this is going to have an X and a Y of CG float dot random in low X to high X. And then we're going to have a Y of CG float dot random in low Y to high. I'm going to force unwrap random color because I know they exist. You could also, set up a default or whatever. All right, and now we need to give our fuel supply a physics body so that we can have our first example of contact detection. We need to be able to detect the contact of the rocket and the fuel supply to be able to give the rocket fuel. So our fuel supply dot physics body is going to be an SK physics body, and it's going to be a rectangle of size fuel supply size. And then we are also going to need a name. Fuel supply dot name equals fuel supply, and we're going to do fuel supply color. Oh, I remember why I did the integer here. Let's go back. Int dot random 0 to 2. Fuel supply colors random color. The reason I did that was because I needed to identify the color in contact by name. So I'm doing fuel supply and then I'm appending the number, because if this is 0, then I know that it is the first index here, which means that it is red. There is other ways to do this. This was the quick and dirty way that I did this for this kind of prototype hobby thing that I'm building here. Now I need to do fuel supply dot physics body dot is dynamic equals false. I'm also going to make sure that our physics body affected by gravity is also false for now. We may change this later. Both of these things, we may have the fuel supplies moving around, they may affect by gravity, but for simplicity, right now, I'm turning these things off. Okay, so now we need to create some bit masks to do contact detection with. So we're gonna do a variable here. We'll do fuel supply category mask is a U int 32, and we're going to do 0x, and this is just going to be 1, 2, 3, 4, 5, 6, 7, 8. So that's just going to be, no contact. We don't want it to actually impact everything, but we need to be able to detect it. So it needs something here, and then we're going to do a ground category mask equals U int 32. This is going to be 0 FFFF 0 0 0 0, and rocket category mask equals U int 32 0x FFFF. For now, this is what we have. And then we need to give these to our things here. So we're going to have a rocket.physicsbody.contact test bitmap, rocket category mask, rocket.physicsbody.category bitmask equals rocket category bitmask, rocket.physicsbody.collision bitmasks equals rocket category mask. And then, of course, we will also have our ground level physics body dot contact equals ground category mask, ground level dot physics body dot category equals ground category mask, and ground dot physics level dot physics body dot collision equals ground. And of course, finally, we also need to give our fuel supply dot physics body dot contact equals rocket. We want to actually not use the fuel supply because we want to test for contact against the rocket. And then fuel supply dot physics body dot category equals target equals fuel supply category, and fuel collision bit mask equals fuel supply category bit mask. And now we are going to say fuel supply plus equals 1. And then we're just going to return our fuel supply. And we need to make sure that we change our, oh, that's why, fuel supply count. Okay, and then inside of our update function, we are going to spawn these, but we don't want to spawn them forever. So we're just going to spawn, we're always going to have, some amount of them. So if fuel supply count is less than 8, add child, spawn fuel supply at rocket dot position. And it's not at the rocket position. It's, remember, a random number in between stuff. So now we have some fuel supplies, but we don't do anything. Like if I go up here, we just go through them, nothing happens. So we need to test for contact, and if we have contact, remove the fuel supply from the scene and apply fuel to the rocket. That is done by using didBegin contact. If you're still with me on this video, give it a like, because these are a lot of work, and likes help YouTube show this to other people on YouTube. So thank you so much for watching. I know these are long, but I'm having a lot of fun with it, and I really enjoy seeing this game come to life. So thank you for watching. Let's dive into didBegin physics now. First, we're going to do guard let node A equal contact dot body A dot node else return guard let node B equal contact dot body B dot node else return. All right, so we're basically saying we have two bodies that collide. We're going to call one of them node A, one of them node B. Now we need to determine which one is which so that we can detect what color fuel supply they collided with, if they even collided with a fuel supply. The first test is going to be if node A.physicsBody.contact test bit mask equals node B.physicsBody.contact test bit mask. All right, so now we're saying if node A and node B have the same contact test bit mask, then we have to do something. If node A.name equals fuel supply.0, or node A.name equals fuel supply 1, or node A.name equals fuel supply 2. So if you remember up above, we append the index of the color to the string fuel supply, and that gives us our name. That identifies which color is associated with which fuel supply. So now we can do if node A dot name equals fuel supply 0, we know that this is red fuel. So plus equals 10. And then we can say else if node A dot name equals fuel supply 1, we know that this is blue fuel, plus equals 10. And then finally, else if node A dot name equals fuel supply 2, we know that we have orange fuel. Okay, so this handles if node A is the fuel supply. But what happens in the case that when these two things collide, node A is the rocket? Then we're never going to find a fuel supply named, or we're never going to find a node that's named fuel supply something, right? That would be node B. So we need to also come down here. We need to basically check for the inverse here, or the other condition. So we're going to have else, and then we'll just paste this in here. And we're going to change these to B. So we have if node B is the name, then I'm going to put this back up here. So now, if node B is named the rocket, then we have this same check here. But instead of node A, we have node B. And now we need to, so now we can run this, and you can see fuel is being added to and subtracted from as we move, right? So we're getting the fuels. But the fuel supplies aren't being removed yet. So up here we need to do node A dot remove from parent. But then if it's actually node B, we're going to remove node B from parent. So now as I go up here and I get a fuel, we remove our fuel from the parent. But we need to also do one other thing to make sure that fuel respawns. Because if you remember in our update function, we're saying fuel supply count has to be less than or equal to 8, and it's going to add a child. So every time we remove a node from the parent, we're going to say fuel supply count minus equals 1. Fuel supply count minus equals 1. So now when I run this and I remove fuel, you can see that we're getting fuel that is spawning, and it's spawning, in relation to where the rocket position is. Sometimes it might be far away, sometimes it might be relatively close. The whole idea is that the player will have to navigate through this world and choose their fuel resource appropriately. And now they're going to have other things to do, so they're going to have to manage their fuel plus other objectives in the game as we develop it. That's where I'm going to stop this video for now. I hope that you're enjoying this series. If you are, please do get subscribed. It does help me out quite a bit. I'll see you in the next one. Bye for now.